Hello. So we are going to be talking about object reference in this video. This is a very fundamental concept to object-oriented programming and also very fundamental to how Python works. So we present this. Now, in my previous video, the intro to OOP, at the end, I asked you to maybe create multiple instances of a class. So hopefully you have done that. And then here is what the code actually looks like. That we have again just a quick review. We have a car class. It's got empty definitions. So for now, we created actually two instances of the car class, and we give it a bunch of attributes. And then we print out car1 and car2. So when I print it out, shouldn't be any surprise. We have two cars, and that's that. Um, Now, one thing I want to point out is, yeah, as I said, car1 and car2, they are two separate instances, right? Because we created a car here, and then we call car parentheses again, so that creates another instance of car. Okay, so what if we instead of creating a new instance here, we assign car1 to car2. Okay, and we change only car2 here. And when we print out both car1 and car2, what do you think we're going to see? Actually, maybe you might want to pause the video and try this on your own if you haven't already, and see if the output is what you expect. So let me run that, and maybe it's a surprise, maybe not. But what it is now is that even though I've apparently only changed car2's attributes, the car1 also seem to have picked up those attributes. Okay? So what happened? Now, to explain that, we have to go back to one of the very first thing we learned when we studied Python, and that's something about a variable. So what a variable was or is, I said back then, is it's a variable is just a name associated with some values, right? So we've done like I equal to 105. So I is a name, 105 is a value, and the variable I is just associated with 105 the value. Right? I think at that time I said this is not the entire picture, but now I'm ready to tell you that's right. It's not the whole picture, but I'm ready to tell you the truth. Okay, so the name, and by the way, I think this is something that Professor Losef also kind of referenced quite a few times in his writings. But I kept saying we're not ready, but now we're ready. So a name in Python is really associated with an address of a location in the computer's memory that holds the value. So a name is not associated directly with the value itself. Instead, it's a name really kind of reference a value. Okay, or it points to a value. For those of you C++ or Java programmers. So a name in Python is always a pointer or always a reference. It's never the value itself. Now, in addition, all values in Python, they are objects. So, right, as we saw, even a simple integer, int, it is an int object, or it's an instance of the int class. So any value, all values in Python, they're all objects. So when you put those two things together, what it means is that a name in Python always references a particular object. Okay, so that is very, very, very important concept in Python. A name always references an object. So what does that mean, particularly for the assignment operator, the equal sign? What does it really do when we say car1 equals to an instance of the car class? Well, so what happened in that statement? Actually, three things happened. The very first thing is that an instance of the car is created. So I kind of draw the picture here because our definition of car is empty. So we create an instance of car, but it really doesn't have anything in it, but it's there. It's just an empty instance. The second thing is that the name car1 is created in what's called a simple table, although, I mean, you're not required to know what a simple table really is, but I'm just drawing it this way so that, you know, this is just really just a table, right, that has two columns. One is the name column. So when we say car1, well, the name is car1. And then finally, step 3, the assignment operation, is that an address is associated with this name. Now, an address in computer is just a big number, a weird number. I mean, a number that most of the time really doesn't mean anything to us. So, but the important thing about that is that the address points to the location, or the address. It's the address of a location in the computer memory where that car object or car instance lives. So you can kind of imagine that the address is really kind of pointing to where an instance or an object is. That's all it is. The assignment operator, really, it creates a reference or change the reference a name is associated with. Right? This is a reference, an address is a reference, and a name is associated with the reference. The assignment operator either creates or changes that reference. So what happens when we then assign car1 to car2? All right, so what happens is that because car1 is a reference, right? We saw, should have drawn an arrow there. Car1 itself is just a reference to a car instance. And so when it appears on the right-hand side of an assignment operator, this name is replaced with its address, which is a reference. So what end up happening is car2 would take on the same reference as car1, which means they end up just pointing or referencing the same car instance of the same object. Okay. Okay. So this is very important. You're assigning a name 1 to a name 2. It just means both of them end up referencing the same object that name 1 reference. Okay, so this is again important. That's why it's in humongous fonts. All right, so now we're ready to understand what really happened in the two versions of the code that we have. So in the first version, we say car1 is we create an instance and assign that instance to car1. So this is the picture we have, and then we create an attribute. We call it Honda, and so we create now an attribute inside this car instance, and then we create another instance and assign that instance to the name car2. So another instance doesn't yet have anything, and car2 points to that. And then we create an attribute in car2 and assign a different value. So that's why when you print out car1 and car2, in this case, they have different makes, right? The make has different values. So, and that's because car1 and car2, they reference different instance of car. All right, so what happens when we change the assignment for car2? Instead of assigning a new instance, we assign a car1. All right, so we start with the same picture. Nothing's new here, right? The difference in the next step. When we assign car1 to car2 takes on the same reference as car1. So car2 is pointing to the same thing as car1. All right, and when we dereference car2, we follow this pointer, go to whatever the instance that car2 points to, and change or update its attribute make. We are changing this attribute and change it to Tesla. And even though this change is made only through car2, the fact that car1 points to the same instance means car1, if you dereference car1 and go to the instance that it referenced to, it will see the new value of make that car2, dereferencing through car2, put in. So, right? So the change is visible through both car1 and car2. All right, I hope that makes sense. There is actually another way other than printing out the attribute value itself to check which instance is which, because each instance of anything actually has a unique ID, and we can do that by printing out the ID. So I'm going to actually print out the ID here. Print car1 ID is that format ID car1. I'm going to change it to car2 and the ID of car2. I'm going to go back to the first case that the two of them are separate instances. Run it. Okay, you can see that car1 has this particular ID, which is different from car2. Okay, and if I, instead of creating a new instance for car2, I assign car1 to car2, you see both car1 and car2, they have exactly the same ID, which means they are the same object, or same instance. All right, so we've done that. We showed that for for a type that we define ourselves. So what about built-in types? Well, it turns out built-in types works exactly the same way. Okay, so let's step through this. When we say a equals to 10, an instance of the int class is created. It will take on the value 10 for that instance of int, and a would reference that int instance. Okay? And then when we say a equals 20, what that will do is that it will change the value of that object to 20. Okay, I pause there to leave you some time to think about it. Is it really what happened? Is that consistent with what we just looked at? Well, hopefully you saw that, but it's not consistent with what we just said. That's not how this actually works. Okay? Because again, the assignment operator changes what the name references, not the object, not the object that it actually referenced. So this should reference a different object, not the object. It does not change the object that it references currently. Okay. And a side note, for those of you who are familiar with C++ and Java, in those languages, the assignment operator works differently for primitive type. So for primitive types, such as an integer, the assignment operator actually copies the values. Okay, but for complex type, like the class that we just defined, the assignment operator changed the reference. Actually, that's only true for Java. It's not true for C++. Apologies, I'm going to change that right now. That's only true for Java. So in Java, the assignment operator does something slightly differently, depending on whether it's a primitive type or a complex type. However, in Python, the assignment operator works consistently because everything is an instance of a class. There's no so-called primitive type. There's no so-called complex types. Everything is an object. Okay, so that's good, but it does slow down the performance a little bit in Python. But that's besides the point. And if you don't get what I just said, it's fine. As I said, it's a side note for those Java programmers among us. So what really happens when we assign 20 to A? Well, this is what happens. A new instance of an integer is created. That new instance or that new object of int is going to hold the value 20. And A, it used to point to 10. Oh, I'm so sorry. All these mistakes. It used to point to 10. It used to point to an instance of int that holds the value 10, but now A points to an instance of int that holds the value 20. This is how it really works. Okay, it's not changing the value of an int object. Okay, and then finally, what happens when we assign A to B is that B now points to whatever A points to. Okay. Another side note is, okay, now that this int object, this number 10, there's nothing pointing to it, right? So what happened to it? Well, if an object or an instance of things, if an object doesn't have anything pointing to it, Python might quote unquote garbage collected, though that's actually not quite true for an integer that is small, but that's really beyond the scope of this course. So most of the time, again, if there's nothing pointing to a particular object, that object is garbage collected. All right, so here's a little exercise for you that even though, I mean, I told you all these things, but you should verify what I just told you were true. So you should, after every step, print out the ID of A, print out the ID of A, and then print out the ID of A and B, and make sure those IDs are consistent with what you would expect, given what I told you just now. So go ahead and give that a try. Okay, so I am going to assume that you have done that, and this is the way I did it. Do I have that? Oh, I do have that. So let me just show that. I have A, I change A to another different value, and then assign A to B. And if I print out the ID, right, the first one is this ID. The second ID after I change A to 20, you see that now A is pointing to a different int object, right? This ID is different from what it was before. And then finally, when I assign A to B, both A and B, they have the exact same ID.